Hello everyone, welcome to the Calibration Calculations Worksheet lecture. I am going to work the problems that are associated with this worksheet. The worksheet is located in the links and literature section on Blackboard for Unit 1, so please go ahead and print the worksheet off. If you haven't done the math, at least you can work it, go ahead and work it with me side by side. Work on it together. But what I'd prefer that you do is that if you haven't done it, at least try to do these math problems on yourself. Choice is up to you. You can work along with me, or preferably at least try to work them out some way or another prior to viewing this lecture. But I'm going to go ahead and get started. Today is June 2nd, 2014. This is for HOR 164 Summer 2014. So we are going to get started with problem number 1. And I'm going to read the problem. It says, a product label prescribes 2 pounds per acre. How much is needed for a 4,800 square foot lawn? Now remember that 1 acre equals 43,560 square feet. So we're going to start with what we know. We know that we have a 4,800 square foot lawn. And I'm going to work this problem just like we've done in the previous lectures. I have 4,800 square feet. I know that 1 acre is equivalent to 43,560 square feet. So I'm taking the information that I already know. I was given a lawn of 4,800 square feet, and I know that there's 43,560 square feet in an acre. Well, the product label prescribes 2 pounds per acre. So, 2 pounds per acre. Now what are we going to do? We're going to cross out what we can. Acre and acre, square feet and square feet, and then we're going to do the math. And that's why I recommend having the handy dandy calculator. So we've got 4,800 square feet times 2 divided by 43,560, and I come up with 0.22 pounds. That's how much we're going to need, almost a quarter of a pound for that 4,800 square foot lawn. Not too much, but we've seen the lecture on how to do it. Remember the Pepsi can problem that we first started out with. And then we moved on into some turf grass calculation. We start with what we know and what we have, 4,800 square feet. We know that there's 43,560 square feet an acre, and we know that we're going to apply the product at 2 pounds per acre. For this one project, this lawn of 4,800 square feet, we're going to put 0.22 pounds of product for this application. That is problem number 1. We're going to go ahead and move to problem number 2. Question number 2. A product label says to use 3 ounces per 1,000 square feet. How much product will you need for a 4,800 square foot lawn? This is a little simpler. But we're going to start with what we already know. 4,800 square feet. Well, it's not asking for acres this time. It's asking for ounces per 1,000. We know that the product label is going to put prescribes for 3 ounces per 1,000 square feet. Next step is to cross out the square feet. So we're going to have 4,800 times 3 divided by 1,000. Work that with your calculator, and you're going to come up with 14.4 ounces. So don't read too much into these problems. Take what you know and try to get what they're asking for. Don't read in too much to these problems. That'll do question number 2. Let's move on to question number 3. Question number 3. You need to spread a crabgrass herbicide over a 2,400 square foot area, and you purchased a 25-pound bag of the herbicide. The label states that the contents of the bag will cover 5,000 square feet. How much of the bag will be needed? Well, what information do we have? We know that we have a 2,400 square foot lawn. A 2,400 square foot lawn. What other information do we know? Well, we know that one bag will cover 5,000 square feet. And we know that there are 25 pounds in a bag. As you can see, I set this problem up where things are going to cancel out, just like in the previous lecture. We have square feet. We're losing our square feet. We're losing our bag. And we're left with the pounds, because the question is, how much of the bag will we need? Well, it's a 25-pound bag. We're figuring out how many pounds we're going to use of that bag. Well, if you do your multiplication, 2,400 times 25 divided by 5,000 square feet, you're going to use 12 pounds of the bag. So almost half of the bag you'll use for this 2,400 square foot lawn. And let me just double check the calculator. 2,400 times 25, 60,000 divided by 5,000. And correct, 12 pounds for the 2,400 square foot lawn. All right, number 4. You need to apply a grub control insecticide over 4,800 square feet. The label instructions says to apply 1 gallon of water and 4 teaspoons of insecticide for each 200 square feet. How much water and how much insecticide is needed? Note what I'm asking for. I'm asking for how much. Well, we know that we have 4,800 square feet. We know that we need 1 gallon per 200 square feet. So really we're working, this is two problems within one problem. Well, this is going to be equivalent to 24 gallons. And now we got to figure out our teaspoons. We still have 4,800 square feet. And we have 4 teaspoons per 200 square feet. Do the math. We're going to need 96 teaspoons. Now, if you've read in your chapters, especially your O&T manual, you're going to notice that we've got 24 gallons and 96 teaspoons. Well, how many teaspoons are in a gallon? I think I looked it up a while ago, and I'm coming from memory, but I think it's 768. So the book takes this problem, or a problem like this, even a step further when they're going to mix the two. Well, you're not actually going to use a total of 24 gallons because you got to subtract for your pesticide. So it'd be like 23 gallons, almost 24 gallons. It'd be a teaspoon's lacking. So if you took the 96 from the 768, you'd have 600 and some teaspoons. So you'd have like 23 gallons and so many teaspoons of water, and then you would have the teaspoons, the 96 teaspoons for your insecticide. But this is what this problem asked for. I stopped the problem here. I'm not going to make you be responsible on the test for going that further. I'm doing the simple math for you guys, and maybe in Unit 2 we'll step it up a notch with math if we have the time. But what I'm doing here, we stop the problem with the question. So only give me what I'm asking for. Don't read in too much to it, and don't give me too much information. Always give me what the problem asks for. So that finishes number 4. We're going to go on to number 5. All right, number 5. You want to make 3 gallons of a 6% solution of a broadleaf herbicide. How many ounces of herbicide are needed and round to the nearest ounce? Well, we know that we got a 6% solution. So how do we write that? Right? Well, doing our dimensionals, we know that there's 128 ounces per 1 gallon of water. And we want to make 3 gallons. We have our 6% solution. We know there's 128 ounces in a gallon, and we're trying to get 3 gallons. So what are we going to do? I'm going to cross out gallons. And doing this math, 6 times 128 times 3 divided by 100 is going to give us 23.04 ounces. And I will double check again with the calculator to make sure. Yep, we are right there where we need to be. So this is problem number 5. We're going to move on to problem number 6. Problem number 6. Determine the amount of granular insecticide needed to treat 4 acres, assuming a label rate of 4 pounds per 1,000 square feet, round to the nearest pound. All right, we know what we have, what we're working with. We're working with 4 acres. What's our square feetage per acre? 43,560 square feet. 1 acre. And we're determining the amount of insecticide needed to treat the 4 acres at 4 pounds per 1,000 square feet. That's our next step. We're going to cross, get rid of our acres, get rid of our square feet. So 4 times 43,560 times 4 divided by 1,000. 4 times 43,560 times 4. I'm getting 696,960 divided by 1,000. And that is correct. 696.96 pounds. So I know it says round off, but really, if we rounded that off to 697, we're applying more pesticide than we need. So I'm going to bring it down to probably 696.5. You know, or if you've got a scale, you can get it pretty close. But you don't want to apply more pesticide than needed. All right, number 7. How much spray solution will be needed to treat a 9,000 square foot lawn if your sprayer is calibrated to deliver 6 gallons per 1,000 square feet? We've already calibrated our sprayer, and we're getting 6 gallons per 1,000 square feet. So how much spray solution will be needed to treat the 9,000 square foot? Asking for total volume, not breaking down water, not breaking down ounces or pounds of the active ingredient. We're just total solution. Well, we know that we have a 9,000 square foot lawn. And we've calibrated our sprayer to give us 6 gallons per 1,000 square feet. It's the only steps we need for this problem, guys. X out our square footage, 9,000 times 6, 54,000, divided by 1,000, and we need 54 gallons for this 9,000 square foot lawn. All right, number 8. A 4% solution of pesticide will contain how many fluid ounces of pesticide per gallon of mixture? Now here we're figuring out how much, of the total solution is water and active ingredient. But it's a small step to do this, guys. We know that we have a 4% solution. So we're going to write our 4%. 4 over 100. And then we know that there's 128 ounces per 1 gallon. And we're doing that so we can cross out. So 4 times 128 divided by 100 is going to give us 5.12 ounces. And guys, if I'm working these problems out a little too fast, hit pause on the video and go back and rework it yourself. You don't have to watch it continuous. That's the good thing about having a video and recording a lecture like this. You can hit pause and play as many times as you need. But 5.12 ounces for number 8. All right, number 9. This is a fun one. You're spraying a pesticide to a lawn. The total lot size is 1/3 of an acre with a 25 by 43 foot house and a 15 by 40 foot driveway. 2 areas that you're not going to apply the pesticide. So how many square feet will you need to spray? Well, we know that it's 1/3 of an acre. We're going to start with that. 0.33, because it's 1/3 of an acre, and 1 divided by 3. 43,560 square feet. 1 acre. That equals 14,520 square feet. That's your total lot size. That's your, property lines, including the house, everything on it. So now what we have to do is figure out the square footage of the house and the driveway. Well, we know that the house is 25 by 43 feet, which is going to give us 1,700 square feet, 1,075 square feet. And then our driveway is 15 feet times 40, which gives us 600 square feet. Well, these are 2 areas that we're not applying the pesticide or the fertilizer. We're going to take these numbers, we're going to subtract from them. So 1,075 and 600 gives us a total of 12,845 square feet total space that we're going to apply the pesticide to the lawn. So we have a lawn that is 12,845 square feet. Well, I'm going to go ahead and erase this and work on part B. This is your answer for part A, 12,845. All right, part B. The label says to apply the pesticide at the rate of 5 fluid ounces per 1,000 square feet. How many ounces of the formulation will you need for this area? Well, we know our square footage. My screen keeps going black. I hope it's not doing that during the video. I'm actually trying a different software to record me writing on the board versus using Camtasia as we do with our slides. But we know that we have 12,845 square feet. We know that we need 5 ounces per 1,000. Again, this is a simple one. Cancel out our square feet. 12,845 times 5 divided by 1,000. It's going to give us 64.23 ounces. And there's your answer for part B. And that completes number 9. Now, number 10 gets a little tricky. You probably wouldn't have been able to figure this one out because you didn't have the problem. Some of you may have Googled it and found the actual formulation to figure this out. Well, let's read it. You're working at a 35-acre horse farm with 30 acres of fenced-in pasture. You need to apply 5 pounds of active ingredient of herbicide per acre to the pasture land. The herbicide is a 60% wettable powder. How many pounds of formulation must you apply per acre? Guys, it's asking me per acre. It's not asking me for total formulation. So the 35-acre horse farm, it's obsolete. The 30 acres of pasture land, it's obsolete. That's information that you don't need to know for this problem. Now, if you were going to do this job, apply this herbicide for the whole property, yes, you need to know it. But to get this math question right, it's asking you per acre. And please write down this formulation. Pounds of active ingredient, abbreviated, AI, pounds of active ingredient per acre times 100. Hope that's still in the screen, yes. So we have pounds of active ingredient per acre times 100 divided by percentage active ingredient in the formulation. So I wouldn't have expected you guys to answer this problem correctly. Some of you may Googled it and found some information through some other colleges, universities on how to calculate this. It's real simple, actually, because we know that we are going to apply 5 pounds of active ingredient. So we got right here 5 pounds active ingredient per acre times 100, and we have a 60% wettable powder. And just work the math out. And it's going to come out to 8.33 pounds per acre. 8.33 pounds per acre. So write down this formulation somewhere in your notes. And then if you were to see this math problem again, say on a test, you know how you're going to do it. Percent wettable powder. You're going to see this time and time again, especially in the lawn care business. And remember this formulation. You may see it on the test. Pounds of active ingredient per acre, which it give us that. Give us the 5 pounds times 100 divided by the percentage of the wettable powder, and it was 60% for this problem. Gives us a total of 8.33 pounds. If, ladies and gentlemen, you were to see a problem like this on your test, you'd have to do the calculations, and then since it is a multiple choice test, you would have 4 possible answers to select from. And being a problem like this, basically what I'm going to do is change some numbers for you. I don't want you guys to really stress over the math on a multiple choice test. It's going to be where you're going to have plenty of time to complete the problems that you have. I'm about almost halfway done writing the test. I'm creating a new one for this summer. So I'm about probably a third of the way actually. So I'll get to the math problems probably tomorrow and hopefully have your test completed in the next couple days and maybe give you guys a chance to get started on it a little earlier. All right, number 11. Your boom sprayer holds 20 gallons of herbicide. It has been calibrated to apply 0.5 gallons per 1,000 square feet. Will you be able to spray an 1.5 acre site without refilling? You're going to tell me yes or you're going to tell me no, but you're going to need to show the math. So we're going to start with what we know. We have 1.5 acres. We know that there's 43,560 square feet per acre. Our sprayer is calibrated 0.5 gallons per 1,000 square feet. And one tank holds 20 gallons. And look what we have here. We have a way to cross out our square footage, our acres, our gallons. We set the problem up that way so we can do it. Well, the acres cancel each other out. The square feet cancel each other out. And the gallons cross each other out. So do the multiplication. 1.5 times 40, oops, made a mistake. 1.5 times 43,560 times 0.5 equals, well, I've got 32,670 for the top. Then we'll do the bottom. 1,000 times 20 is going to be 20,000. So I'm going to divide that 32,670 divided by 20,000. 32,670. I'm typing too fast. Divided by 20,000. I'm going to need 1.64 tanks. So it asked me, will you be able to spray the 1.5 acre site without refilling? The answer is no. No, no, no. Because I'm going to have one full tank and then 0.64 of the next tank. And we could actually figure out how many gallons that is, guys, but it asks you per tank. Are you going to have to refill your tank? You're going to have to refill it. I mean, you can't do it without refilling it. So the answer is no, and it'll actually take 1.64 tanks to complete this application. So that's number 11. Number 11, you're applying a fungicide to a circular patch of turf with a radius of 75 feet for a public garden. The application rate on the fungicide label is 4 ounces per 1,000 square feet. How many ounces of fungicide will be needed to treat this turf? Well, let's start with what we know. We know that we have a circular patch of turf with a radius of 75 feet. So there's our circular path of turf. Our radius, 75 feet. Well, we all should know that the area of a circle is pi r squared. So the area equals pi r squared. What does pi equivalent to? It is equivalent to 3.14. We have our radius of 75, which is squared. So keep dropping this down. 3.14. 75 squared is 5,625. And that's going to give us 17,662.5 square feet. There my screen went blank again. We have 17,662.5 square feet. Well, I do have room over here, so well, now we know our area. 17,662.5 square feet. 4 ounces per thousand. Cancel out the square feet, and we're going to get 70.65 ounces of product needed to do these calculations. All right, this concludes number 12, and this also concludes the lecture on calibration calculations worksheet. Again, you know, I hope that you tried working the problems prior to watching this. If not, hopefully you worked it alongside with me. So if there's any questions, please ask your classmates on the discussion board, or you can send me an email. And have any questions about the homework, please put them on the discussion board. I did have a question early this morning about the flies and how whether or not it was relevant to horticulture pesticides. Guys, that wasn't the point. The point was I was trying to get you to watch the lectures, and also it is relevant to what we're studying because we were talking about natural pest controls. Natural pest controls is a great benefit to us, and that's why we don't have to apply as many pesticides as we do. So that was the relevance of that problem to what we're studying. To do the homework, you're going to have to read the chapters. You're going to have to watch all the lectures because the questions are pulled from that, and the answers aren't going to jump out. You're going to have to dig into this information. You may have to read it and kind of do some of your research on your own to get these homework questions right. But the idea of the homework, guys, you have unlimited time, chances to do it. You can submit your homework and say, I've missed 4 problems. Well, you can go back and it's going to tell you the ones that you've missed. Work on those 4 problems, resubmit it. Everybody should have 100 on their homework. There's no excuses for that because you have unlimited chances to do it. Work the problem, submit it to see if you got it right or if you got it wrong. If you've got it wrong, go back and correct it and submit it again, and you'll get it right. So I want to see everybody make 100 on their homeworks, and I hope everybody does great on the first exam. I think you're going to if you've done the material, if you've read your chapters, if you've watched the lectures, if you've done this worksheet, you're not going to have any problems passing these exams. So with that being, I will see you guys in the next lecture. It'll probably be for Unit 2. You're not going to have any more lectures for Unit 1. So the only way you're going to communicate with me is through the discussion board or through email. With that being said, I'll see you in Unit 2, and thanks, guys.